Vijayawada-1 from the K.B.N college. Today's my topic is on junction diode. Generally, what is a diode? Diodes means it's nothing like a switch which is used to operate for only in a forward bias condition. And then coming to the what is a forward bias condition. Generally, a diode is used like a switch for on and off purpose. In this diode, we have a P-N type of diode. In this, what is P means positive type of particles are present over there. What are the positive type of particles means they are holes. Holes are the positive type of particles over here, and N type of particles are of electrons. Electrons means they consist of a negative charge on it. So combinedly P and N junction means which consists of both a positive type of particles and a negative type of particles in it. So this positive type of particles that of holes and the negative type of particles that are for electrons, both combinedly present in a junction diode, which makes them to work out. In this, we come across of two functions like a forward bias condition and a reverse bias condition. Generally, what is a forward bias condition means conduction when we give a power supply. When we need to operate a diode by giving a power supply to it. What you meant by giving a power supply to means just like giving voltage source as an input. So when you are giving a voltage power supply as an input to the junction diode, the P type of holes conduct with the N type of particles. So due to this conduction, the junction between the N type and P type gets break down and the conduction starts. So due to this conduction starting, there is a flow of current in the diode. So this flow of current makes the diode to come into a on part. So by allowing a current through the diode, it's coming to the on condition or a working condition. In a reverse bias condition, the electrons and the holes doesn't have any conduction over there. There is only a minimal amount of a current passed through it. So there is no passes of a current in a reverse bias condition. So in this way we can say that a diode can operate in a forward bias condition only. It doesn't operate in a reverse bias condition. Why it doesn't operate in a reverse bias condition means there is no passes of a current in a reverse bias condition. Why there is no current means there is no breakdown of a depletion layer in a P type and a N type layer. So the diode works only in a forward bias condition and it does not operate in a reverse bias condition. Generally, these diodes are used for on and off purpose. So what are the applications present in a diode? What is the real-time applications we can come across when you are using a diode means generally these diodes are used in two type manner, just like a half-wave rectifier and a full-wave rectifier. So what is a half-wave rectifier? Generally, what is a rectifier? Rectifier means which is used to convert AC power supply into a DC power supply. Generally, we are giving a diode with a power supply. In this, we get a DC power supply as an output by giving a AC input. So when giving a input as a AC, we get the output of a DC in it. So in this half-wave rectifier, this is the symbol for the P-N junction diode. Here we are discussed like this is a P type and this is a N type, and this is the terminals which have a diode has, that is of an anode and a cathode. This is a symbol for the P-N junction diode. Where it is used means in a half-wave rectifier. So it already described that it uses a AC power supply to convert it to DC power supply, and then in this half-wave rectifier we have only one diode, and this is the circuit diagram for this half-wave rectifier. In this, we are giving a AC power supply to this circuit, and we are having a transformer over there, and the diode is connected to the transformer, and the load is connected to this diode. In this, we are giving a power supply, and this power supply is connected to the step down transformer. So what is a transformer? Transformer generally is used to transform one level of voltage to the other level of voltages. It does not doing any conversion process over here. It just decreasing a level or increasing a level of a voltage we are giving. In this transformer, we are giving a AC power supply to the transformer. This transformer is used to here mainly we have two transformers. They are step down transformer and step up transformer. Here we are using a step down transformers. These step down transformers are used to step down the input voltage. So here we are giving a input power supply. This power supply is stepping down and then it is given to the diode. So why are using a step down transformer means here we are giving a voltage of a 230 volts, but 230 volts voltage is not applicable to this diode. Diode takes merely of 0.7 volts of voltage. So in order to decrease this voltage, we are using a step down transformer over here. So this step down transformer decreases the voltage level and is given to the diode, and this diode conducts for the forward voltage and then it's given to this load. For this half wave rectifier, it's only conduct for only a half wave. Means generally the AC power supply is represented with a one positive half wave and one negative half wave. This for only a positive half wave, the diodes come into the conduction. When we are giving the negative half wave, the diode doesn't conduct, means it doesn't allow a current pass away. So, and the next application for the diode is a Fourier rectifier. In this Fourier rectifier, we have two diodes. These two diodes are of a D1 and D2. This why we are coming across of a Fourier rectifier means generally half wave rectifier gives efficiency of only a 40%. So when we are giving input of 100%, but it only gives an output of a 40% only. There is a lack of a 60% we are getting. So in order to increase the efficiency of a rectifier operation, we are using a Fourier rectifier. For this purpose, we are using two diodes over here. So two diodes like a D1 and D2. Same, just like we are giving a power supply to this Fourier rectifier through the step down transformer and is given to the D1 and D2. Here once power supply is given to the step down transformer, it decreases the voltage and is given to the D1 and D2. In the forward bias condition or for the positive half cycle, only the D1 diode conducts. So the current passes through the step down transformer through the D1 and from D1 to the R1, and it is closes through again a step down transformer. This way the current flows from a D1 only. In mean one condition, the D2 is in a off state. So then when a half wave circuit, when a negative half is given to the as an input to the circuit, then the D1 is in off condition and D2 come into the on condition. In this, the current passes through step down transformer D2 and from a D2 to resistance load, and is again ends with the step down transformer. So here for the positive half cycle D1 conducts and for the negative half cycle D2 conducts. So for the output we can have both positive half wave and negative half wave in this output. Just like one input is given for the first half cycle D1 conducts and for the negative half cycle D2 conducts. In this way we can get two pulses. So in this way we can get a efficiency of 80%. In earlier case, in a half wave rectifier we get a efficiency of 40%. In this Fourier rectifier we have got a efficiency of 80%. So in this manner we increase the efficiency. We are using devices for the better performance. So in order to have a better performance, we prefer a Fourier rectifier over than the half wave rectifier. And then this is a formula for the efficiency. But generally, what is the efficiency means? Efficiency is used to determine the performance of the application. So this is the formula for the efficiency: DC output by AC output. And then filters. Filters are generally used to rectifier. We are getting a DC output from the rectifier, but there is some pulsations or ripples in the output. So in order to have a pure form of output, we have to inculcate the filter name. So filter, which is used to filter or eliminate the unwanted substances which are present in the output. So in order to have a desired output, we need to fix the filters. So in this we have two types of filters, that of a L-type filter and a Pi-type filter. In this L-type filter we have a capacitor and the inductor. So this is a diagram for the inductor and a capacitor, which consists of a L section filter. So here we are giving a output from the rectifier to the inductor and capacitor. This inductor and capacitor rectifies the output into a purified DC format and is given to the resistive level. And then we come across of a Pi filters. So in order to have a more efficient or a more smooth or more purified output, we can have a Pi type of a filter. In this Pi type of a filter, we have a one extra capacitor over here. When power supply is given to the rectifier, it is given to the first capacitor and then given to the L section, that is of a inductor and a capacitor. And we come across of a voltage regulators. Generally regulators means which is used to regulate the output voltage. Why we need a regulators means in order to have a stable output we need to have a regulators. Generally this regulators are of a we generally use of a 78 series and 79 series. In this we have a 78XX. This XX represents the voltage that we get as a desired output. So this has the diagram. This diagram you can see that the 7805, which means 78 means a series number and 05 is the output voltage we get from this voltage regulator. So this 05 is a output voltage we get from this voltage regulator. So they have a 3 pins. This pins, this one is the input and second one is the ground and third one is for the output. So by using this circuit we can get the output of a 05. Why we know that this gives output of a 05 means it's indications like a LM7805. In this name itself it's giving as a 05, means 05 output as a output. It can discuss over here. And next we can come across of a 79 series. In the 79 series same, just like a input, output and ground. This is the diagram for the 78 series, this one. And when input is given to this 78 series, it gives an output as of our requirement. And how is LED works means, what is the LED means? Light emitting diode. This light emitting diodes is given with the input of a 5 volts and we get output as a light. Its input is a electric power and it gives output as a light in the form of a light. This is a symbol or circuit for the LED. Here we are giving a supply voltage and it is connected with the resistor and this resistor is connected with the LED. Why we are connecting a resistor means in order to oppose the current flow, in order to protect the LED from the unwanted currents. So we are using a resistor. In order to oppose the unwanted currents we are using a resistor over here. And then photodiode, just like a LED, this photodiode works similar to the LED, but here the input and output varies. This photodiode takes the input as a photo and gives the output as a electrical energy. In LED it takes the input as a electrical power and gives the output of light. In the photodiode it takes the input as a photons in the form of a photons and gives the output as a electrical energy. This is the symbol for the photodiode. And then we have a light dependent resistor. This is one kind of a resistor which opposes the flow of electrons. This resistor is dependent upon a light. When a light incident on this resistor, the current or voltage varies. Means light dependent resistor is inversely proportional to the light intensity. When the light is incident on this light dependent resistor, the resistance in this circuit varies. Here we have a coating of a cadmium sulfate over the LDR. By using this material in a zigzag manner, the light will receives the photons energy and it converts into the photon energy, and then this resistor varies depending upon the energy band. So this is all about the diodes and half a rectifier and full rectifier. Thank you.